Hi, my name is Medicine. Bachelor of Information Technology and Business Systems, Network Architecture, 2019. A recent picture of myself. In this video, we'll be talking about the OSI model, TCP or IP, and Internet model. The purpose of the OSI model and different functions of the layer. The open system interconnection is a reference to understanding data communications between any two network systems. It divides the communication process into 7 layers. It helps understand the big picture of networking, helps users understand how hardware and software elements function together. It makes troubleshooting easier by separating networks into manageable pieces. It helps users understand new technologies as they are developed. It aids in interpreting vendor explanations of product functionality. It defines a networking framework to implement protocols in layers with control passed from one layer to the next. It also defines terms that networking professionals can use to compare basic functional relationships on different networks. There are 7 different layers in the OSI model. Number 1, the physical layer. 2, data link layer. 3, network layer. 4, transport layer. 5, session layer. 6, presentation layer. And 7, application layer. The first layer is a physical layer that defines connector and interface specifications as well as the medium requirements. The fiber optic cabling is often used for the physical layer in the vertical or riser backbone link. There are components of the physical layer which include cabling system components, network interface card which is known as the NIC, wireless system components, and note, the physical layer of the OSI model is only part of a LAN which is a local area network. The second layer of the OSI model is the data link layer. This layer provides the following functions. It allows the device to access the network to send and receive messages. It offers a physical address so each device's data can be sent to the network. It provides error detection capability. There are common networking components that function at layer 2, which are the NIC, Ethernet and token ring switches, and bridges. The third layer, which is the network layer, provides an end-to-end logical addressing system so that a packet of data can be routed across several layer 2 networks, which can be known as the Ethernet, token ring, frame relay, etc. The Internet uses IP addressing to provide connectivity to millions of networks around the world. Some basic security functionality can be set up by filtering traffic using layer 3 addressing on routers or similar devices. The fourth layer is known as the transport layer. It provides the transparent transmission or transfer of data between systems or hosts and is responsible for the end-to-end error recovery as well as flow control. The most common transport layer protocols are the connection-oriented TCP, the connectionless UDP, which stands for User Datagram Protocol. Layer 5, the session layer, provides various services, including tracking the number of bytes that each end of the session has acknowledged from the other end of the session. Session layer functionality includes creation of dialog units, connection parameter negotiations, acknowledgement of data received during a session, visual connection between application entities. Layer 6, the presentation layer, it is responsible for how an application permits the data to be sent out onto the network. It also allows the application to read or understand the message. Example of the presentation layer is the system-specific translation, context translation, graphics formatting, encryption and decryption of message for security. The last layer is called the application layer. It provides an interface for end user operating a device connected to a network. This layer is what the user sees in terms of loading an application such as a web browser or email. That is, this application layer is the data the user views while using this application. Example of application layer is it supports for file transfers. It has the ability to print on a network, electronic email, browsing through the World Wide Web. The purpose of the TCP or IP model and the different functions of the layers of the TCP or IP model. TCP stands for Transmission Control Protocol, while IP stands for Internet Protocol. The TCP part has to do with verifying delivery of the packets, while the IP part refers to the moving of data packets between modes. The TCP or IP has then been the foundation of the Internet. It is important because the whole Internet runs over it. Without TCP or IP, the data communication and Internet or internetworking of the devices will not be possible. The different layers of the TCP or IP model are network access, Internet, transport, and application. The TCP/IP model uses 4 layers to perform the functions of the 7-layer OSI model. The network access layer is functionally equal to a combination of OSI physical and data link layers, which are 1 and 2. The Internet layer performs the same function as the OSI network layer. Number 3. Transport, also known as the host-to-host layer of the TCP/IP, is complicated. If the host-to-host protocol is TCP, the matching functionality is found in the OSI transport and session layers number 4 and 5. The TCP layer, process layer, or application, when used with TCP, provides the functions of the OSI model's presentation and application layers, which are number 6 and 7. When TCP or IP transport layer protocol is UDP, the process layer's functions are equivalent to the OSI session, presentation, and application, which is layer 5, 6, and 7. The purpose of the Internet model and how it differs from TCP and IP model. The purpose is to share and distribute information via networked computers. It makes access to information and communication far easier. It has a huge impact on businesses, allowing employees to work remotely from home and communicate more efficiently. The TCP or IP is a standard protocol used for every networking, including the Internet, whereas OSI is not a protocol but a reference model used for understanding and designing the system architecture. TCP and OSI are two most widely used networking models for communication. The TCP or IP enables only connectionless communication modes in the network layer. The OSI model supports connectionless and connection-oriented communication over the network layer. That is the end of the video. We have discussed the OSI model, its 7 layers, the TCP or IP model, and its 4 layers, and the purpose of Internet and why it differs from TCP and IP models. Thank you.